We now get on to bond pricing. As with any other asset, the price of the bond is the discounted value of the cash flows it produces. Now a bond, as you know, produces cash flows C every period till maturity, when it produces the last coupon C plus face value. So you can break up this cash flow into two parts. One is an annuity, which starts from period 1 and continues till period T, where T is the maturity of the bond, and the other is this face value. So one is an annuity for T periods, and the second is a face value. So the price of a bond then becomes the value of the annuity for T periods plus the discounted value of face. So the value of annuity for T periods is the coupon divided by the rate of discount R, which is also called the yield to maturity, into 1 minus 1 divided by 1 plus R to the power T, plus the face value discounted T periods. So that is plus F divided by 1 plus R to the power T. So this is the price of a bond. Here is a question for the price of a bond. We have this firm with a bond with face value $100, coupon payment of $8 every year, maturity 2 years, and the market price is 81.67. The question is, what is the yield to maturity? So we have this bond it pays $8, and 2 years from now it pays the coupon of 8 plus the face of 100, so that's 108. So you can either use the annuity formula, or because there are just 2 periods here, you can use the cash flows discounted directly. So it will be $8 divided by 1 plus yield to maturity plus 108 divided by 1 plus yield to maturity square, and the answer would turn out to be 20%. So 81.67 equals 8 divided by 1.2 plus 108 divided by 1.2 square. Next we have a bond which is priced at $807.50. It's a face value $1,000 bond. The coupon payments are $60 annually, and the bond matures in 10 years. So the first question is, what is its coupon rate? Well, coupon rate is the coupon payment divided by face value. So that would be $60 divided by $1,000. That would be 6%. The coupon rate is 6%. The next question is, what is the current yield? Current yield is defined as the coupons divided by current price. So that would be $60 divided by $807.50, and that would be 7.43%. So the current yield is higher than the coupon rate because the bond is trading below par value. If it's trading below par value, it is called a discount bond. Is this actually the rate of return which bond buyers will get? The answer is no. They'll actually get a bit higher rate of return because they'll be getting 7.43 from the coupons, and at the last period the bond is going to pay $1,000, whereas they paid only $807.50 for it. So they are also going to make a capital gain. So their actual rate of return is going to be higher than the current yield. So the actual rate of return is what we call the yield to maturity, and that can be found from applying the formula for bond price. 807.50 should equal the annuity value of the coupons, which will be 60 divided by yield to maturity into 1 minus 1 plus yield to maturity to the power 10 plus the value of the face, which is 1,000, divided by 1 plus yield to maturity to the power 10. And this you can solve by either using a financial calculator or using trial and error. You try a particular value for yield to maturity. If the price turns out to be too high, then you increase the value of yield to maturity, because that means that the cash flows have not been discounted at a high enough rate. On the other hand, if the price for the yield to maturity that you are trying turns out to be too low, then you decrease the yield to maturity, and like this, by trial and error, you can approach the answer if you're not using the financial calculator. And the answer turns out to be that the yield to maturity is 9%. If you're using the financial calculator, these are the steps you'll go through. First, press second and FV to clear. Then press 10 and N to enter the number of periods equal to 10. Then enter the price that you're paying, 807.5 plus minus, and then PV. So that's for present value minus 807.5. Then for the periodic payments, enter 60, then PMT. Now this also has a cash flow on the last day, which is 1,000. So this is an annuity plus one more cash flow on the last day of 1,000. So enter 1,000 and then press FV for the payment on the future date. So with that, you've entered all the data required. Now you want the calculator to compute it, so press the CPT button and then press I by Y, and the answer it gives is 8.999. Which is the same as the answer you'd get from trial and error, that the discount rate is about 9%. Now we're going to do a question in which you will have three different yields to maturities for a bond, and we'll see how the price changes. So first we have the bond with $1,000 face value, and the yield to maturity is 10%. The annual coupon is $100. So the required rate of return for these bonds is 10%, and the coupons are also 10%. So the present value of face would be $1,000 divided by 1.10 to the power 10. 1.10 is 1 plus R, and that equals $385.54.